In this video here, we're going to go over the introduction to graphing absolute value functions. I'm going to give you the formula and just kind of show you how it changes the way your graph of your absolute value function is going to work. You need to make sure that you understand what these variables are, how to identify them in a absolute value function, and know how to plot your graph of the absolute value function given these different things. So the first thing you have in the front is your value for a, which you can think about as your slope. Okay, remember with the linear function, you have positive slope, which is increasing this way. You also have your negative slope, which decreases, goes down from left to right. Your slope also tells you like how steep or how the steepness of your graph, right? So if you have a slope like up 1 over 10 on a graph, you would go up 1 and over 10. Okay, so that's not going to be a very steep graph. If you have a slope of like say 10 over 1, that's a big difference, because if you have a point here, you're going to go up 10 and over 1. Okay, so that one there is going to give you a pretty steep slope, and this one here is not going to be very steep at all. So this one's not steep. Okay, one thing that you need to notice is that when you have a fraction here, it's actually going to make your graph wider. Okay, so that's considered a stretch. Okay, if you have a whole number here, like you see here, it makes it very steep, so it changes very quickly. So it's going to make your graph more narrow. Okay, and we call that a compression. Okay, so when we're talking about this value for a out here in front, we're talking about three different things. The first is it going to be positive or negative? Okay, if it's negative, then it's going to be reflected across the x-axis. It's going to be going in the opposite direction. If it's a compression, it means that it becomes more narrow, okay, and it's going to be a whole number. Okay, if it's a stretch, it means that it's going to get wider, and that's going to be because you have a decimal or a fraction out front. Okay, so your slope here, in terms of whether it's a compression or a stretch, it's kind of counterintuitive. It's opposite of what you think is going to happen. Your h, which is going to be inside the absolute value sign, it's also going to be in the opposite direction, and that's your horizontal translation. So that's going to tell you whether it moves left or right from the origin. Okay, and that's opposite direction, because this negative here, it's actually part of the formula. So if you pulled out your point from there, it's going to be opposite of that sign because of that negative there. So that's going to kind of change it. And in the examples, I'll show you a little bit how that works. Your K, your vertical translation, so that's going to tell you if it's going to move up or down. Okay, and then your vertex can be found at the point HK. So your H is dealing with your X values, okay, so left or right, your X axis, and your K is dealing with your Y values, up and down. Now you also have your axis of symmetry, which is the line X equals H, so whatever your value for H is. In both of these instances, your H is opposite of whatever is in the formula. Or of the function, I should say. Okay, so if you have a negative 2 here for H, this is going to be positive 2, and your axis of symmetry is going to be the line X equals positive 2. Now keep in mind, guys, that your axis of symmetry is a line. It's not a point. So you need to give it to me X equals, you need to state that it is a line. X equals whatever that number is. Don't tell me that the axis of symmetry is equal to 2. Okay, that doesn't tell me anything. You need to tell me it's X equals 2. Another thing that you should know, I abbreviate axis of symmetry AOS. Okay, so if you see me write AOS, I'm talking about the axis of symmetry there. So here we have the parent function for absolute value, okay, that one right there. That's our parent function. There is no a value out here in front. There's no h inside the absolute value sign, and there's no k out here on the outside, which means that h is 0 and k is 0. So if we just wanted to make a table real quick of values so that you could see what's happening here. So if I take some negatives, -2, -1, 1, 2, okay, and then put them in the function. So we know that the absolute value is the distance from 0. So you're just going to take the positive. So the absolute value of -2 is 2, absolute value of -1 is 1, and then all the way through. Okay, so these aren't going to change, 0, 1, 2. And your absolute value, your sides, they function kind of like your linear functions. Okay, so 2 here. So at -2, x equals -2, we have a +2. At -1, it's +1, 0, 0. At +1, it's +1. And at +2, it's +2. So you can see here, pretend those are straight lines, that's your absolute value function. It's opened up. If you wanted to take the slope of the line, remember your slope is rise over 1, so if I look at that here, that's up 1, excuse me, and over 1. So that's the slope of +1 there. And in the same way, any number that you have out here for a is going to affect your slope. If we want to look at this one over here, we don't have a value for h, there's no value for k, but we do have a value for a right here. So a is equal to -1. So let's see how that affects your table of values. Okay, so x, negative absolute value of x, f of x. -2, -1, 0, 1, 2. Now here the negative is on the outside, not on the inside. So that's going to change what you have. Here. So the absolute value of -2 is +2, but when you multiply that by that -1 there, you're left with the -2. The same thing here, absolute value of -1 is +1 times the negative is -1, 0 times any number is 0, +1 times the negative is -1, and then -2 here. So we have the same pattern that we had with the parent function, except for now, it's going in the opposite direction. So at -2, it's -2. At -1, -1, 0 at the origin, +1, -1, +2, -2. Okay, so now instead of opening towards the top, it's opening down towards the bottom there. Our slope is still 1 over 1, up 1 over 1. Well, it's up 1 here, negative direction there. So your slope here, your m, which is the same thing as your a, is going to be -1, which is what we have. That's what that means here. So that's what the reflection looks like, okay? So if it's a positive a, it's going to open towards the top. If it's negative, it's going to open towards the bottom. Here are a few more examples. I'm just going to help you identify the vertex and see how it moves left or right. Okay, so in all of these examples, our slope is 1, there's no reflection. I just want to show you how the h and the k affect it. So remember, your h is always inside and opposite. So h is opposite sign. Okay, and that tells you if you're going to move left or right. And then your k, it stays the same and it's just up or down. Up or down. So if we look here, we have h is +2 and k over here is going to be equal to 0. So your vertex is going to be at the point -2, 0, which means that it's going to shift to the left. So if you were graphing that on your point, you would have -2, 0, and it would open upwards, okay? The same thing over here. We have no a, it's just 1. Our h is in here, our k is on the outside, so our vertex is h opposite of -1. So instead of moving to the left, it's actually going to move in the positive direction, so +1, 0. On our graph, we would have the point 1, 0 here, and it opens upwards with the slope of 1 on both sides. Here, there's no k on the inside, so k is equal to 0. I'm sorry, h is equal to 0. We have a k here on the outside, so k is equal to 3. So your vertex is now at 0, 3. Now the k works intuitively. Okay, so if it's plus 3, you know that you're going to shift up 3 units on the y-axis. Opens upward with a slope of 1. Okay, so that's 1 over 1 there. Here in this next example, h is equal to 0 because it's not in there. Okay, and we have a k is equal to -1. So on your graph, it's going to shift down 1 unit. Okay, you still have your axis of symmetry here at the line x equals 0. Here, your axis of symmetry goes through your vertex at the point x equals -2. And here your vertex goes through that, or your axis of symmetry goes through that, or that vertex, excuse me, at x is equal to +1. In the next video, I'll show you a couple more examples of graphing absolute value functions, and I'll also show you how to write the function given a graph. If you have any questions, let me know in class. You should be able to get started on the 2.2 quest homework. Okay,